This is Professor B, and we are going to talk about expanding logarithms today. All right, so we are going to go over logarithms. Think of it is the inverse of an exponential function, but we are going to expand them. Okay, so we're going to take one logarithm and we're going to break it up into a bunch of different logarithms. All right, first thing that we're going to do, my mild examples are going to all be over one property per, so you can see what each property looks like before we go on to some milder and some medium and spicy examples. All right, so the first one we're going to look at is this is called the product property. Okay, product because the items within the argument of the logarithm are being multiplied, hence product. Okay, so if you have a log base b, does not matter what the base is, of two items being multiplied together, those can be numbers, they can be variables, they can be a number and a variable, anything. If you have two products being multiplied together, then they can be expanded. So this one logarithm can be broken into two logarithms where you are adding the separate arguments. So you would break apart m and n to be the log base b of m and the log base b of n. You are adding because that is what multiplication is repeated addition. Sorry about that. Okay, a couple things to keep in mind. Your bases will stay the same. So whatever the base is to start with, that is what the base will be of every subsequent logarithm. Okay, all you're doing is breaking apart the argument into two separate logarithms. Okay, arguments will stay arguments, the base will stay the same. So taking a look at an example of this one, just a mild example, okay? If we take a look at this example right here, we have the log base 7 of 2x, okay? Anything that happens after you say the word of is your argument. So even though you don't see parentheses around this part right here, that whole entire thing is your argument, okay? I've said this before. If you say your math out loud or think it out loud as you would say it to another person, it makes more sense as to what the properties are and what you're going to do. Okay, so this is log base 7 of 2x. So I said base 7, so that's going to be the base of every one of my logarithms. Okay, I am going to break apart the 2x. Okay, so that means that it is going to be the log base 7 of 2 plus, so here's the first part. This would be my m if you wanted to follow along with the pattern. This is my m, and this would be my n. Log base 7 of 2 plus the log base 7, bases stay the same, of your n, which is x. So notice here, these two arguments of my two separate logarithms, this is the original argument when you put those together. Okay, so all we did was break apart the multiplication of the arguments into addition. All right, and this would be the expanded form of my original problem. Okay, all we're doing right now is expanding. We're not solving anything. We're just learning how to break apart these logarithms. So let's take a look at the next property. So the next property, this is called the quotient property. Okay, so we will be dividing. You'll see division. All right, you are going to have the log base b, again, does not matter your base, of something divided by something else. That something, again, could be numbers, could be variables, could be a combination of the two, but all you're focused on is that it is going to break apart, just like the product broke apart to be addition, division is going to break apart to be subtraction. And it is always going to be numerator minus denominator. Okay, so we broke apart our division into two that we subtracted. All right. So taking a look at the mild example for that one, we are going to have the log base 3 of x divided by 5. Okay. This time you see the parentheses, so you know that whole thing is your argument. Our base is still going to stay the same. So I said log base 3 out loud, so I'm going to have log base 3. And then remember, if it helps you, here's your m and here's your n. So this is my numerator, this is my denominator, and then we're going to subtract the 2. So this would be log base 3 of x minus, because it's dividing, the log base 3 of 5. Okay? Again, your bases stayed the same. That doesn't change. And your broken apart argument is the argument of the two separate logarithms. So again, this is your original argument. Okay? And this is going to be your expanded version of this guy. All right? Third property. Third property is called the power rule. This is the power rule, okay? What happens here is, again, you have the log base b of something, again, variable, number, doesn't matter, raised to a power, okay? So this is an exponent within the argument. Okay, it is an exponent in the argument. All right, and all it does is it gets to come from being an exponent and travel all the way in the front to become a factor. Excuse me. Okay, so notice instead of being an exponent, now it is a factor. Factor, remember, means multiplication. So we are changing that exponent to be just a multiplication. All right. So for that mild example, I have the log. Notice I don't see a base down here. That's okay. Remember, if you don't see a base, it is just an understood 10. If you don't see the base, it's an understood 10. So we could read this as log base 10 of x to the third power, or x cubed. Okay? And all we're going to do is to expand, this is expanding again, we're going to take that 3 as a power and we're going to push it out in front of the logarithm. So then we're going to end up with 3 times the log of x. Again, your base will stay the same. So this is log base 10, or you heard me just say log of x because that understands that it's a 10. And the exponent came out in front. That's the end of the power rule. That's all you've got for that guy. Okay, so we've gone over three rules now. We have the product rule that breaks apart multiplication into addition. We have the quotient rule. This breaks apart division into subtraction. And then we have the power rule that brings an exponent to the front to be a factor. All right. There are two other properties. They're very closely related, but we want to make sure we understand them. This is the identity property. Okay. We have the log base b of b equals 1. Notice that your base of your logarithm and your argument are the same. Again, they could be variables, numbers. All right. So the base of your if the base of your argument is the same as your, I'm sorry, I said that wrong. The base of your logarithm is the same as the base of your argument, your answer is going to be 1. That goes back to the idea of an exponential function. If you think of it like this, if I said b to the first power equals what, you're going to tell me that it equals 1. I'm sorry, that it equals b. Good grief. So we've got b to the power of 1 equals b, because anything to the first power is itself. This is just the reverse of that. So if you have the log base b of b, that will equal 1. So your mild example of that is the log base 7 of 7. Again, your base and your argument are the same. Since those two things are the same, the answer is simply 1. Okay? You could also kind of ask yourself this question: what power do you raise the base to equal the argument? So I'm asking myself the question, what power do I raise the base to equal the argument? So what power would you have to raise 7 to equal 7? It'd be the first power. All right. This question might help you with the last property that we're going to talk about. It again relates very much to this one, except what if you had that exponent? Okay. You could use the power rule if you want to and expand this, but there's a little bitty shortcut, a cheat to this. So if I take a look here, I have the log base b of b to the x power. All right. That's just going to equal x. Because again, if you ask yourself that question I just did, what power would I raise b to get b to the x? Well, you're already raising b to the x power, so x would be your answer. All right. A little bit easier to understand if you take a look at this example. I have the log base 3 of 9. Okay. So two ways I want you to look at this. The first way I want you to look at this as you could rewrite 9 as 3 squared, right? Those two are the same thing. Those two mean the same thing. So I could rewrite this as the log base 3 of 3 squared. And then I've said before, your base of your logarithm and then my argument are the same. So then the answer would just be 2. Okay, it's that exponent. But if you want to think about it, that question I asked, what power would you raise 3 to get 9? Okay, so I'm going to say that as or because this is a different way you could think about it. What power would you raise 3 to? Here, I'll just put that as a question mark, to equal 9. Well, 3 to the second power. So that means that the log base 3 of 9 is 2. You're asking what power you raise the base to. Okay, just a couple different ways to think about this. All right, so those are your mild examples. All right, those are your easy examples of what we're going to go through with our expanding. So let's go on to a slightly trickier one. Okay, so here is your medium. We are going to expand the given logarithm into multiple logarithms. All right, so we're just going to expand this as much as possible. I have right here for you guys, this is kind of like an order of operations when it comes to logarithms. This is for expanding them, all right? For expanding them, we have the quotient rule first, if it applies, the product rule, if it applies, and then the power rule, if it applies. This is just like order of operations with PEMDAS. If you don't see parentheses, you're not going to use that part of PEMDAS. You're going to move on to the other pieces, okay? So I'm first going to check for a quotient rule. There is no division, so I am going to skip that one. Okay. The next is my product rule. Is there anything multiplied together in my argument? Again, we're looking at our argument so we can break all these pieces apart. Yeah, absolutely. I have 4 times x squared. So I'm going to break those two pieces apart. Okay. Remember that your base is going to stay the same. So I'm going to have the log base 2 of 4. This would be my m, and this would be my n. If you are breaking apart product, product is going to turn into addition. Remember, you're going from multiplication to addition. Quotient is going from division to subtraction. Okay, so we have the log base 2 of 4 plus, because we're multiplying, the log base 2 of x squared. Okay, so we broke apart our 4 times x squared. All right, that's our product rule. The next thing that we are going to do, this might help too. I'm going to write from here to here, we used the product rule. Then what I'm going to do is I'm going to see if I can use my power rule anywhere, right? Order of operations. We did quotient, there wasn't any. We did the product rule, now we're going to look for power, okay? Power goes from an exponent to being multiplication, okay? So I see that there is a power right here, okay? There are no powers in this first one, so I'm going to just copy this first piece down, not changing it at all right? Plus this power right here, 2, is going to come out in front, okay? That's what you do when you expand that power rule, right? Exponents become factors. So I'm going to write 2 log base 2 of x, okay? So between this line and this line, we did the power rule, all right? And last but not least, when you are expanding these logarithms and you are cleaning everything up, don't forget to simplify. So how are we going to do that? Well, we're going to take a look and see if there's anything we can use those fourth and fifth rules that I showed you on. For instance, take a look at this guy right here. I have the log base 2 of 4. Well, I know 2 and 4, you can raise 2 to a power, right? I could make this 4 become a 2 squared. So what power would you raise 2 to get that 4, to get that 2 squared? You would raise it just to the second power. That's how I know that's a 2. And then there is nothing else to simplify here, so I just get to copy everything. 2 plus 2 log base 2 of x. And that is the expanded version. I know we only ended up with one logarithm. That's okay. We still broke it apart into 2. All right? So that is your medium example of expanding logarithms. Okay? Let's do a spicy example and then we'll be done for the day. All right? Spicy example. The only thing that makes this spicier is you're going to incorporate as many rules as possible, and they might try to trick you with what you see right here, which is a radical. Do not let that trick you, okay? We just got to go back to our rules of exponents. So we're going to expand this logarithm, right? We're going to use the same rules we did for our medium. We're going to go quotient rule, product rule, power rule, order of operations, all right? Remember, for all of these, our base is going to stay the same. We don't see a base down here, so we know it is an understood 10. If it helps you to see that and visualize it and remember it, write it down. Don't be afraid to write more down, okay? So we've got quotient rule first. Well, I do have a quotient rule in this one. I have my numerator here and my denominator here. Cool. So I'm going to break those apart. Remember, division becomes subtraction. So this is going to be the log of the square root of 2x, that's the whole numerator, minus the log of the whole denominator, which in this case is 10. Okay? So that, from here to here, is me using the quotient rule. Next, what I'm going to do is I'm going to tackle this guy right here, because I can break this apart more. All right? Log of 10, that second part, I can't break that apart anymore. I can simplify it. I'll do that at the end. So what I'm going to do is I am first going to rewrite this part, this radical, I am going to write as an exponent. All right? If you remember your rules of exponents, that means that if you have, do a little sidebar over here, if you have some number to the square root, okay, that means you have that same number to the 1/2 power. 1/2 power and square root mean the same thing. Remember, again, just like we have all these understood numbers, if you don't see them, for a square root, the understood number is a 2. So the root is a 2. Roots go on the bottom. And then the exponent, if there was one, would go on the top. There isn't one that we see, so again, we understand it's a 1. That's where we get those numbers from. Okay? So I'm going to just rewrite this guy as the log of 2x to the 1/2 power. Again, I'm just going to copy the log of 10. All right. So I rewrote the square root as a power because there's no rule for radicals with logarithms, but there is a rule for powers. So we just have to change the way something looks. All right. So then what I'm going to do is, again, I'm going to use another rule of exponents, and I'm going to share this 1/2 with everything in my argument so that everything gets the power, okay? Just because everything was under the radical, so everything gets the power. Again, rules of exponents. So we've got the log of 2 to the 1/2 power times x to the 1/2 power. So I just distributed my power to each piece. Minus the log of 10. Okay? So again, what really makes this spicy, it's not the properties of logarithms that makes this a spicier problem. What makes this a spicier problem is knowing your rules of exponents. That's what really gets it. Okay? So that we did the quotient rule. That's all this right here. And then now we're going to do the product rule because look, I have 2 to the 1/2 power times x to the 1/2 power. So let's break that apart now. Okay? Breaking that apart, I am going to get the log of 2 to the 1/2 power plus, product becomes addition, the log of x to the 1/2 power minus the log of 10. So from this line to this line, I did my product rule. All right, keep going. So next what we're going to do is I am going to do the power rule. Again, order of operations. We did quotient, we did product, so now we're going to do power. Here's a power. It gets to come out in front. Here's a power. It's going to get to come out in front. And those are my only powers. So I'm going to pull those powers to the front. I'm going to end up with, I'm going to zoom out a little bit. I'm going to end up with 1/2 times the log of 2 plus 1/2 times the log of x. And then I'm going to skip a step just so I can move on, minus the log of 10. Remember, this is a base 10, so I'm going to go ahead and simplify this part. The log base 10 of 10, my base and my argument are the same number. That means that that simplifies down to just be a 1. Okay, and there is my final answer. Multiple logarithms and everything simplified. Okay, so go over your rules of exponents if you struggle a little bit with that, because that's what makes these problems spicy. Beyond that, it's just quotient, product, power. Okay, if you have an extra question, please leave a comment, like the video, that'd be great. If you want to see a different type of video content, example, anything, leave a comment, let me know. Otherwise, I will see you next time in class. Bye.